Hello. So today I'm going to talk about communicating science results effectively, particularly data science results. We have been graced with Tuki today because he's just woken up from his afternoon nap and is feeling very cuddly. So that's happening. Enjoy. Okay, cool. Okay, let's see if I can get this. Okay, there we go. Yes. Okay. Oh, there we go. Okay, cool. So let's talk about communication. Cool. Yeah, so how do we communicate effectively? Thank you, Dukes. So, recall that there are 5 core activities for data science. And these kind of fall in the same kind of flow chart that Hadley Wickham's data science or R for Data Science book has, which I've reproduced that figure down there. But the 5 steps are stating and refining our question, exploring our data, building formal models, interpreting our results, and communicating those results effectively. I definitely encourage you to check out The Art of Data Science, a guide for anyone who works with data. It's pretty helpful and is the basis for chunks of these slides. So let's start with stating and refining our question. So there are kind of like, well, not exclusively, but there are approximately 6 kinds of questions, and these map on pretty well with my experience in consulting, both for academic and industry positions. And often they're not asked, the questions aren't asked in a really straightforward way. It's not like somebody comes to me and be like, I have an exploratory problem. I need to know if there are patterns or trends in the relationship between this data set and that data set, and here's the uniting index. No one hands you that because they would not be paying me the silly amounts of money they pay me to do these things if they had the entire project already lined up. Now, half of the beauty and fun of data science is you're usually given vague questions that you get to like figure out what types of things you can actually answer based on the data you have. So here are the question types broadly. So we got descriptive, and that's all about summarizing some characteristic from your set of data. This can be summary statistics. It could just be a way to give other people a sense of what is happening. There's not really any analysis beyond like, here's what we got. I mean, there can be, but in the prototypical question, it's just, we want to know what's in our data. Tell us. We got this bucket, but we don't know what to do with it. So the next type is exploratory, and this one is all about analyzing patterns and just uncovering relationships and just seeing what's in there. This is often kind of viewed as like a hypothesis generating process. Often exploratory is contrasted with confirmatory. And apparently, I am not interesting. Chucky? What? What? Okay. Maybe? He's deciding. What do you want? Alright, well, I don't know if you can hear that, but that is why I have to go through chairs very often. Yes, okay, so Tukey has decided that I am not worthy of any more of his attention, because I'm giving it to you and not to him. Okay, so that's exploratory. It's just to see what's in there, what their relationships are, and just if there's stuff worth poking into. Next, we got inferential, and this is just analyzing those trends and relationships in representative data from a population. And so this could be still in the same flavor, but your idea is to try and see if these can be generalizable, maybe. Then we got predictive, which is about making predictions from data and then applying those predictions to other data. It's more than just descriptive. Your goal is to be accurate in the future. Next, we got causal, which is obviously very simplified here, but do changes in one factor cause changes in another? You'll see lots of kind of experimental A/B designs and things like, does this blue look better than that blue, and does it lead to actionable results? Industry tends to be more interested in causal, like whether you can make the change and it is effective, as well as exploratory, even just so you can like then test it. While academia is much more interested in inferential analyses and mechanistic, our sixth type of question, which is all about exploring the how, explaining why stuff happens. For most of you experiencing this course, you will be shocked to hear that I don't have a ton of interest in mechanisms, even though that's really where classic psychology goes. I just want to play with data and see what it tells me. And so I'm very much an causal inference, descriptive, and exploratory gal. I mean, mechanisms are interesting, but you know, I have to leave room for the rest of you. Right, so here's an example that it's either going to be a little too on the nose or not. So here are just some examples of looking at the COVID and vitamin D. So descriptive would be frequency of hospitalizations due to COVID in a set of data collected from a group of people. Exploratory could be examining relationships between a range of dietary factors and COVID hospitalizations. Inferential. So at this stage, we are examining whether any relationship between those variables occurs in something that is closer to representative and is not just like exclusive to our weird wonky data set. This is a way to avoid overfitting. That's why machine learning tends to have training and test samples so that they aren't just overfitting and over-exploring and over-predicting. Because when you overfit a model, your predictions are going to be shit outside that model for the most part. Okay, so predictive questions are like, what types of people will take vitamin D supplements during the next year? So we want to identify kinds of people to see what they will do in the future. Will they successfully take more vitamin D? Let's see if people with COVID who are randomly assigned to take vitamin D supplements, sorry, that sentence is not properly parsing in my brain. So whether people with COVID who were randomly assigned to take vitamin D supplements are more likely to be hospitalized than not. Is there some kind of possible causal mechanism, at least from a Cook and Campbell standpoint, where we're eliminating plausible threats? Mechanistic, how does that relationship work? Why would there be an association between vitamin D and COVID? So how does vitamin D intake lead to a reduction in the number of viral illnesses? So questions to data science problems. So here are the things you should be asking yourself. Do you have appropriate data to answer your question? Or at least, do you know where you can find some? So that could be web scraping, publicly available data sets, proprietary data. But the question is, like, do you have a way to answer this? Next, do you have information on confounding variables or on alternative explanations? Because you need more than just the two pieces of the two variables that you're interested in. You need to, at least, for the most part, you want to eliminate plausible threats to validity. And in addition, when you have more variables, when you go through the exploration process, it is much more rewarding and fruitful when you include more than just three, because there are only so many ways to slice up three variables. Yeah, there's a very limited number. I mean, yeah. So anyway, and was the data you're working with collected in a way that could introduce bias? So the data production process, as well as the data that gets to you, what are the pathways in which error and bias could be introduced into this data stream? It could be as something as straightforward as, say we were looking at continuation of census data. The 1890 census was like totally destroyed in the fairly soon after it was collected, and so there's a big genealogical gap. And there, the handfuls of data that survived, they're not representative. They actually, because it's not like the fire was random, or so try and understand how the data got to you is what I'm trying to say here. Through the data cleaning process, did you just like omit rows where you had any missing data? Because any non-random missingness, if you then exclude that row, introduces bias. In addition, even like through the data cleaning process, say you are trying to scrape out data and there's some issue where certain like characters aren't encoded properly, and those rows get dropped, or you only go through and have a stopping rule for yourself and say, okay, I'm going to spend 4 hours cleaning up this data. Anything else, if it doesn't get cleaned, I'm done. That data just gets removed. I mean, that was a little obvious, but my point is that you need to think about all the steps in your data. And although it is lovely that data just like shows up in your life, you have to ask why and how it got there. Because first of all, that's usually a really interesting question. And it gives you more context so that you can ask the right kinds of questions. Now, for example, say I were to estimate the average number of children in households in Winston-Salem. Here is how hypothetical me is going to go about it. So I'm going to conduct a survey of elementary schools in Winston-Salem and ask students how many kids, including themselves, are in their house. And then I'm going to average their responses. Is this a biased or unbiased estimate of the number of children in households in Winston-Salem? I'm going to let you think about that one. Now, if biased, will this value be an overestimate or an underestimate? Because that information is also important. So if we have bias that's systematic, so it's in one direction or another, that can help us as well as bias that is on average random. All this information is important and all this critical thinking is important. Don't just accept data unquestioningly and think about your data production process. Cool. So, I think I'm gonna cut it here because Tukey is summoning me, and we'll talk about exploratory data analysis in a bit.